Hello class. In this video we want to talk about the central limit theorem problem. Central limit theorem problem is going to be different than the normal distribution problem because as we did on the normal distribution problem, we are in the normal distribution problem, we are finding a probability of selected like one person or one object. But the central limit theorem applies to the finding probability of average of a group. Okay, so there's a significant difference here. Okay, normal distribution, finding actual probability of a one single person, object, and so on, and whereas the central limit theorem, we are finding probability of average of a group. So there's a couple of things that we're going to have to be careful when we use the central limit theorem, because from the outcome of the sampling distributions, we found out that population mean is the mean of sample mean, and the standard deviation of a sample mean is population standard deviation divided by and square root of n. And also, if the original population is not normal distribution, then n must be greater than or equal to 30. Okay, that's usually the case. Okay. However, if the original population is normally distributed, then n doesn't matter. Okay. I said that n is greater than or equal to 30 because that's the mostly n that we have used. Okay, so let's look at the problem here. We are looking at the central limit theorem problem here. So man's weight is normally distributed with the population mean is 172, and the sigma is equal to 29 pounds. Okay, so if you go out on the street and you gather the 36 men and you write down all the weights of each man, then you find the average. Okay, now what is the probability of that average weight is going to be less than 167? Okay, so that's the question there. So we are going to look at that. Okay, so the first thing we're going to do is, just like the normal distribution problem, we are going to draw the two graph here. Oh, sorry, I need to go back here. Here. Okay, sorry. Alright, let's draw that. Okay, so we're going to draw the normal distribution. Then we're going to draw standard norm. Okay, so here mu is equal to 0 and sigma is equal to 1. Here we are given that mu is 172 pounds and sigma is equal to 29 pounds. Now the problem here is that I'm going to use a different here color. Since we are applying the central limit theorem, we cannot use this, but we're going to have to use mu x bar. However, it says the population mean is equal to mean over sample mean, so this is not going to make any difference. But this one will. Okay? Since we are dealing with central limit theorem, you must use this, right? Okay, so now sigma is 29 and divided by square root of n, that was 36 men. This is the one that you're going to have to use when you find the conversions factor to find the z-score. So let's find out what we have here. So you got 29 divided by 6. You got 4.83. Okay, so I have here 4.83. Now we still want, okay, the weight, which is less than 167 pounds. So I'm going to draw the line here indicating that average weight x bar equals to 167. And this is the area we want. Okay? Now, be sure that you are using the x bar here because we are trying the average weight. Right? Okay, now we go to find the conversion factor now. So now z becomes x bar minus mu x bar divided by sigma x bar. So here x bar was 167, mu mean over sample mean was 172, and then divided by sigma x bar was 4.83. And that makes a difference because if you're going to divide it by 29, you're not applying the central limit theorem, you're just doing the normal distribution problem, right? So you're going to have to be careful. Alright, so let's find out what that number is. Okay, so you got 167 minus 172. Right, is that right? Okay, and divided by 4.83, I have about 1.04, minus 1.04. Okay, so now we come to the standard normal distribution there. So now we are looking for z is less than minus 1.04. Okay, so that would be over here, and the z equals to minus 1.04. So that's the shaded area we want. Okay, now since the shaded area is on the left, we can directly find what that area is. Okay, so let's find out what that is. Go ahead and use the table. Look at the negative z-scores. So look at the minus 1.04. I have 0.1492. Okay, so that would be the shaded area. Okay, that over there. Okay, so that means about 15% probability that, you know, when you select the 36 men, that you would, the average weight of that 36 men's weight, okay, the probability of the average weight of that 36 men is going to be less than 167 pounds, only 15%. This kind of makes sense though, because if you do that, normal distributions, okay, actually you do that, you know, you get about, I don't know, about 40%. So you're going to have to somehow, you know, look at these two different normal distribution probability and, you know, central limit theorem probability. You're going to have to compare that, see if they make sense. In other words, that if the, for example, let's say, you know, in normal distribution, you found out that the, you know, the weight less than 167 pounds is, let's say, 1%. Okay, for example, and then you found out that the, you know, using central limit theorem, the average weight of 36 men, you found the probability is going to be, let's say, 40%. Now that doesn't make any sense, because if you select the one individual, one single person randomly, and their probability is going to be less than 167, it's going to be less than 1%, and you have a 36 men, you're going to get 40%. It doesn't make any sense, because every time you select the 36 men, there's only 1% chance that, you know, the man's weight is going to be less than 167, and how can you have, let's say 40% if you have 36 men? So, you know, you're going to have to compare the probability outcome that you get from normal distribution and central limit theorem, see if they make any sense. Okay, so this was just the example of trying to explain what the you can just punch in numbers and get the numbers without understanding what those number means. Okay, so if the normal probability is very small, okay, then when you apply the central limit theorem, then those are going to be even smaller percentage, because the probability of selecting that in normal actual probability is going to be smaller. Then you're not going to see that kind of it's not going to be average value into it. Okay, so if there's a reasonable probability of the one single person being selected as a greater than 167, then I would also expect that when you have average, there will be a man weight more than 167, so I will see that more average with the higher probability. Okay, so you're going to have to be careful, not just punching numbers, but make sure that you understand what this number means. Okay, because if you cannot understand what number means, okay, it means nothing. Okay, you just have to, I mean, we can always go back and, if you make a mistake about this numbers, how do you get these numbers and stuff. But if you don't have any understanding what this number means, then, you didn't learn anything. Okay, so make sure that let's understand what this number means. Okay, and so when you try to write the conclusions, you can write it properly, okay, without making any mistakes. Okay, all right, thanks for coming, and I'll see you in the next video.